Hello everyone, this is the North American Math Contest Go Go Go. Today we'll be talking about a question from the COMC contest in 2022. So let's start with the first question, A1. John had a box of candies. Right? On the first day, he ate exactly half of the candies and gave one to his own little sister. For the second day, he ate exactly half of the remaining candies again and gave one to his own sister. On the third day, he ate exactly half of the remaining candies and gave one to his little sister again. At which point, no candies remained. How many candies were in the box at the start? So first of all, I feel very sorry to the sister because we know that the answer is going to be large, but like he eats a lot of candy, but only gives her sister three of them. It's bad. Yeah. If you have a sister, do not learn him. He's a bad child. Okay, so let's talk about how to do this problem. We know that in the end he has no candies, right? So the end is 0. Now let's intuit it from backwards, like intuit it in the reverse order. So we know that in the end is 0. So what is going to be the number of candies before he gives one to his sister? Well, it's going to be 1 because 0 plus 1 is 1. Sorry. Okay, and now the next thing is what is going to be the number of candies before he eats half of them? Well, it's going to be 2 because 1 times 2 is 2, right? So after he eats exactly half, there's going to be 1 candies. So this means that before he's eating an exactly half, there's going to be 2. So this is going to be on the before the third day starts, he's going to have 2 candies. So it will be like this. Just give me a sec. It will be like this. Days. At day 3, or eating exactly half, he's going to have 2 candies. Let's talk about day 2. Day 2, day 2, day 2, day 2, day 2. Uh, at the end of the day 2, we know he has 2. So what is going to be 2 candies? So what is going to be the number of candies he's going to have before he gives one to his sister? Well, it's going to be 3 because 2 plus 1 is equal to 3. And what is going to be the number of candies he has before eating exactly half? Well, it's going to be 6 because 3 times 2 is going to be 6. So this means at the start of the second day, he's going to have 6 candies. Now let's start from day 1. What is going to be the number of candy he's going to have before giving one to sister? Well, it's going to be 7 because 6 plus 1 is 7. And then what's going to be the number of candies he has before eating exactly half? Well, it's going to be 14. So in this case, the total is going to be 14 candies. Let's test it from the reverse order to see whether it is correct. Oh, sorry. Let's start from let's intuit it. In the start, there's 14 candies, and 14 divided by 2 is 7. 7 minus 1 is 6. 6 divided by 2 is 3. 3 minus 1 is 2. 2 divided by 2 is 1. 1 minus 1 is 0. Okay. So now let's see. Now let's see the second question. A palindrome is a whole number whose digits is the same when reading from left to right as from right to left. For example, 565 and 7887 are palindromes. Find the smallest 6-digit palindrome divisible by 12. So from this problem, we can see that the 6-digit palindrome should be in the form of A, B, C, C, B, A. To divisible by 12, the number itself must be divisible by both 3 and 4. To be divisible by 3, in this case, we can use the math. So this means that the sum of every single digits in the palindrome must be divisible by 3, which in this case, we have to make A plus B plus C plus C plus B plus A divisible by 3, and make it as small as possible. To be divisible by 4, on the other hand, we have to make AB as small as possible, which in this case, AB is going to be as small as like AB must be BA must be like divisible by 4. So we start with the condition 2. BA must be divisible by 4. Therefore, the smallest possible value for A is going to be A is equal to 2. Why? Because like any number with a single digit of 1 cannot be divisible by 4, given that any number with a single digit of 1 is going to be a odd number. At a is equal to 2 and b is equal to 1, smallest possible way of us it is the smallest possible way, because we can set b as 0, but if we set b as 0, then 0, 2 is not divisible by 4. So in this case, we plug in 2 and b1 back into condition 1, so that the condition 1 becomes 6 plus 2c is divisible by 0. In this case, c is going to be 0. C can be 0. I mean, the smallest value in order to make a plus b plus c plus c plus b plus a divisible by 3 is that c is equal to 0. So in this case, hence, a, b, c, c, b, a is 210012, which is going to be a palindrome. We're then going to test it to see whether it actually works. 210012 divided by 12, it is equal to 17501. Now let's do A3. A3. Initially, there are 4 red balls, 7 green balls, 8 blue balls, 10 white balls, and 11 black balls on the table. Every minute, we may repaint one of the balls into any of the other 4 colors. What is going to be the minimum number of minutes, which the number of balls after each of the 5 colors is going to be the same? So now let's see this question. Well, let's see this question. Let's assume in order for us to write it more better, we are going to set it as 1 is red, 2 is green, 3 is blue, 4 is white, 5 is black. Okay. In this case, and for every action we make, it will count as 1 minute. Let's see. 1, 2, 3, 4, 5. So, just give me a sec. 1, 2, 3, 4, 5. So what we are going to do in the first step is that we are going to paint red, one black and 2 red. So in this case, we have 1 more red and 1 less black. So in this case, we have 5 red, 7 green, 8 blue, 10 white, 10 black. We did the same thing for step 2 and step 3. In this case, we are going to have 7 red, 8 blue, 3 green, 9 green, 8 green, 7 red, 7 blue, 8 green, 10 white, and 8 black. So we see in this condition, we need 1 more for both red and blue, while we need 2 less for both white, right? White. So in this case, we just do like this. Paint 1 white to red and paint 1 white to green. In this case, it becomes da 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 da. So in this case, we can see this 8 red, 8 blue, 8 green, 8 white, 8 black. So in this case, there is going to be 8 of them in total. 8 of them in total. So 8 for each color. Now let's look at the problem 4. Problem 4. In the diagram, ABC lies between 2 parallel lines as shown. If segment AC length 5 centimeter, what is the length in centimeter of the segment AB? So from this, we can see CA line. We can see that. So we can see that angle C is 73. According to the Z theorem, everyone learns on grade 8. Angle A is going to be 73 degrees. Since BA angle is 13 degrees. CAB angle is definitely going to be 60 degrees. Let's look at point C. We know from grade 8 again that the flat line has a degree of 180 degrees. 180 minus 73 minus 17 is going to be 90 degrees. So in this case, we are able to intuit that angle B has 30 degrees. Okay, given that the angle of ABC forms a 30-60-90 triangle, the ratio of the three sides is going to be CA to CB to BA is going to 1 versus root 3 versus 2. So in this case, since we know CA is 5 centimeter, BA divided by CA is equal to 2 divided by 1, so this is equal to 2. So in this case, we need to time it by a multiple of 2, which in this case, BA is equal to 2CA. It's going to be equal to 5 times 2 is equal to 10. Here, we come to the end of our lesson, and I hope you have learned a lot. See you next week. Bye-bye.